dirty nozzles, retraction issues, over extrusion, carbon fiber, and weird noises coming from my printer. All this and more. Print Fail Friday, episode 9, where failure is always an option. We're gonna make it less of one. Let's get into it. Why do I need to change my nozzle after every other print? I just installed this nozzle less than a week ago and it's already ruined. Is my nozzle temp 220 too high? And what is the best way for me to clean these nozzles and to use them again? Let's take a look at these photos. We've got this first nozzle, and we got that, and we got that. These nozzles are not ruined. There's gunk buildup, 100% there's gunk buildup, which likely leads to you're either over extruding, you are, 220 is probably too high, run a temp tower and find out. But these are Creality style nozzles, and 220 PLA on a Creality, generally speaking, is too high.
It's too damn high.
But these nozzles are not ruined. We can see some gunk buildup in there. This is pretty typical of dealing with nozzles. I would hedge that they've got some issues with retraction and potentially some issues when it's moving. These nozzles are not borked in any way. There are some really awesome tools to help you keep this from happening. One, silicone sock. Now, it won't immediately keep the nozzle specifically from having problems, but it can keep this from happening on the rest of your block. If you don't have one, put it on there. It's cheap insurance. You're gonna find out what that looks like later in this video, so stay tuned. But with this, a brass cleaning brush. Copper works fine too. Do not use a steel cleaning brush because steel is harder than brass and will damage your nozzles. You can get these brass cleaning brushes cheap as chips from the firearms industry. I'll put some links to some down in the description. That's what we use. We use firearms cleaning brushes. They are awesome for cleaning off nozzles because they're really long, like they're 8 to 12 inches long, and they've got two different sides, one with lots of bristles and one with just a few, so you can get that fine detail where you need it with stiffer bristles or the longer bristles for just easier work like this. But this much buildup leads to other problems. I'd like to see what your prints look like, and then let's take a look from there. I believe that we've got some other issues that are pointing toward this particular problem, but this is not a reason to replace a nozzle unless you're running like carbon fiber through it. But considering this looks like a generic red of some sorts, it's probably not carbon fiber. Is this my y-axis banding? And I don't know if they're talking about lines. You can see that there's some deviation in the lines there, or if they're talking about the retraction marks. So I'm going to assume they're talking about both and cover both. So first thing, this here, this angle is not y-axis banding. That is retraction. That is all due to retraction tuning. It looks like you are de-retracting too much. I can see a blob right on the start of the line, and you are, I think you've got a little too much coast in there maybe, or you're retracting too much and you're not wiping enough. Knowing what slicer you have is useful. Let's see if we literally have no extra information. Cool potatoes. But I do see some banding here, right? So we have a line there, another line there, another one, another one, another one.
Another one.
There's banding. This could be the filament. It could be the z-axis. It could be temperature related. But the walls themselves look reasonably clean. So I have to guess that this is just color. This is just a color-in thing with the filament. We see some ghosting, so you see those vertical lines. That's ghosting from when the printer is making the hard corner here. it is vibrating as it is printing, and it is not all that strong. Like, the mechanism is not that stiff, so it tends to vibrate a little bit. If this printer has V wheels, go ahead and make sure those are nice and tight. We went over that in our Ender 3 maintenance video. We'll card to that so you guys can go take a look at it. But I think realistically, let's work on getting rid of the ghosting. Let's fix your retraction issue there. And then let's see if this Z-axis issue still goes, because this Z-axis issue that I'm seeing, it's kind of obvious when we look further down. That might be related to loose V-wheels as well. In that same Ender series, we also worked on an Ender 3 Pro that had lots of loose V-wheels that was contributing to print damage. So verify that all of this is good first. Get those retractions in line, and then let's see what you might be considering Y-axis banding. I'm not seeing any Y-axis banding. If we were seeing Y-axis banding, we would see it in the corners for sure, and these corners look pretty darn straight to me. Do have a bit of an elephant's foot down here, or some sort of layer inconsistency. I don't know what this little layer right there is where it bumps out, but there is some inconsistency. Let's get some of these settings tuned and let's go from there. But I don't think this is Y-axis banding. I'm fairly certain that is a I'm dead certain that's a retraction issue. Pretty simple to fix. Will take a little bit of time. That is okay. Please help, okay? We're helping. Let's see what we got here. We've got some photos. Good high res. All right. First and foremost, you are too close to your bed. Stop it.
Stop it.
Go ahead and redo your Z offset. We can see some extra BS here. And the reason I'm going with your too close is we can see quite a bit of overlap. I would bet that we can see it here. Yeah. Oh, you might be over extruding. You're definitely over extruding here. Could be a bit of both. You might be too close to your bed, or you might be over extruding. Set those steps per millimeter. Yeah, you're over extruding. Okay. Well, we've got some layer squishing down here, which leads to first layer too close. But we have some over extrusion right at the corners with a very obvious ghosting line there and another one there. So yeah, we got lots of ghosting lines. Your printer needs to be tuned. I think you're over extruding. Let's see what the comments say. It's a CR6 SE, Cura Slicer, Community Firmware, 6.1, 210 nozzles, 60 bed, PEI, bed is level, X is level, 16mm Z offset. That's a lot of Z offset. Good Lord have mercy. Any idea what I should change to make the prints better? We have a commenter saying linear or pressure advance would help with those corners. That's true. It absolutely would. Linear pressure advance might even take away a fair bit of the problems that we're seeing. So real quick, linear advance is toward the end of a line, the extruder will just stop extruding because there is pressure built up in there. And especially with Bowden systems, this is incredibly common. To solve this issue, you can tune in this pressure advance or linear advance so that it runs out of filament right at that corner, so you get a really, really clean corner. That's what it's about, is getting those clean prints. Now, it can be a bit of a bear to get working, so be careful. That one is absolutely a trap for young gamers. I think here instead, we should look at tuning the steps per millimeter. We reviewed that in the Ender 3 Pro video. We'll card directly to that video so you can see it, but is also inside of the Ender 3 playlist, which we carded to earlier in the video. We'll link to everything in the description down below as well. But this, to me, looks like your first layer is way too close, because we can see where it's squishing out there. And this top layer screams either I'm trying to iron unsuccessfully, or because of this corner right here, I'm over extruding like crazy and I need help. Let's start with tuning that extruder. And I think that we're gonna end up getting some better prints that way. What is happening here? Well, let's take a look. You have poor retraction. Or you likely actually have no retraction. Let's see if we get any help here. Ender 3 Pro modded with dual gear direct drive, all metal hot end, 4.2, 7 mainboard, BL touch, most recent Marlin. Acceleration is 500 millimeters per second squared. Outer shell speed 60 millimeters a second. Materials PETG, sliced in Prusa slicer. Well, hey, good on you for using Prusa slicer. Acceleration is a little bit low, but is fine. The outer shell perimeter at 60 is too fast. Well, maybe it's not. With the all metal hot end, you should be able to run that fast. I might lower that, though. Run your inner shell that fast all dang day. On our Prusas, we will run our inner shell at like 100, 120. The outer shell is like 35 or 40. Get those crispy, clean exterior perimeters, because in 3D printing, it's only on the outside is what matters. Mark Forged. And the inside, hey, nobody else sees it until it breaks, so why worry about it? That's a joke. Worry about the inside of your parts, please, especially if they are not just for show. If they're just for show, don't worry about the inside. But if they also have to work, please, dear God, do it right. This is a PETG thing, and I just don't think they've got enough retraction, so work on tuning that retraction. We see, well, I'm a little concerned. I need to see what else is on that print. But it seems like it's relatively consistent. You might be running a little too hot. Do we have temperatures? Might be running a little hot. No, we don't have temps. I'd like to know what the retraction is set to here, because PETG can be a little bit picky, especially with a Bowden system. My theory here on the retraction side, and it's because I have dealt with it, like, I've dealt with it. We'll go over this in an upcoming Print Fail Friday, so get subscribed if you want to see me talk about that failure. That is all about trying to run stupid fast on a small nozzle, and that's a back pressure problem. Because no matter what I did, I ended up with a ton of back pressure, and I think we might have a back pressure problem here as well. How do we fix this? Well, we look at adjusting our retraction settings. You can pull it out as hard and fast as you want, but you must put it back very slowly. This is a ramming setting. The easiest way around this is to like retract somewhere in the 60 millimeters a second or so, and then de-retract something like 30, 35 or less. That should help with this back pressure issue, but I have a feeling they're probably retracting very quickly, which is causing a lot of back pressure and a ramming issue that is leading to this problem. We could be seeing a retraction problem as well, and PETG is a bit tricky, especially on Bowden style printers, but the dual gear direct drive, oh shit. So I didn't notice that I even said it earlier, I didn't notice it's a direct drive. Yeah, okay, so direct drive, probably running the Bowden profiles, that might be your problem. Work on that retraction. I would like to see how this looks, how this dual gear direct drive looks, because that is a mod I'm looking to do on ours. All metal hot end is great. BL touch is great. Most recent Marlin is fine. Yeah, I'm still sticking with retraction, and retraction is more of a problem with Bowden 2 printers. With direct drive, it's not that much of an issue, but still play around with the ramming settings. It's not going to hurt your direct drive printer. It's only going to help your prints look better. Ender 5 Pro. Can anybody help me identify this ungodly sound? Well, let's see what we can do here. This almost perfectly sounds like an extruder that is a little bit upset. And here's why I'm thinking this. Let's dial it back a little bit and let's listen. Right as it's getting to the end of a line, we hear that noise, right? It sounds like that they've got their pressure advance set so that it is effectively retracting toward the end of a line like that. that's fine. But for small parts like that, you're effectively going to keep grinding your filament like crazy. Check your extruder pressure. You might have way too much spring pressure on that extruder causing that noise. Your bearings could be going bad in the extruder itself, but I'm fairly certain just kind of the way that that is in line with the movement of the printer, that is a pressure / linear advance problem. That's just my thought. I'm fairly certain that's what it is. I asked the user about this, but never heard back, so maybe posting the video will help. But I do believe that this is all due to linear advance. If they go and they remove it, which you could easily do inside of your slicer, and then reprint it, if you don't hear that anymore, that was your problem. We messed around with linear advance on our Fusion 3 F410 to try to get it to do crispy, sharp corners. And we heard this identical sound, because at really high linear advance numbers, it's going to go whap, 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 whap with the filament constantly. And by the way, that's not good for your filament. So we actually ended up taking off linear advance because it just made things more complicated. We get better prints with it on, but we also have a much higher chance of the print itself failing because of extruder grinding through the filament. Not too bad, but that's my particular guess. It could be a Bowden tube related thing, and we do have some Capricorn Bowden tube on the way, and I am so excited about this because I'm gonna get to test Capricorn Bowden tube versus the generic crap versus the cheap crap, and I've got a fair bit of the cheap crap laying around. So I want to see how good is CapTube, and if you want to see how good CapTube is, make sure that you get subscribed, because I'm fairly certain this is just regular blue Bowden tube. It is not CapTube, and there should be a difference. We're going to test that. Should be a lot of fun, just like my segue to our sponsor, 3D Musketeers. If you want to get your ideas out of your head and into your hands with full art-to-part rapid prototyping and product development, you could reach out to us, 3D Musketeers. We make 3D printing simple. You see this entire series, PrintFailFriday. I'll even card to the whole dang thing so you can take a look. Printing is not all that easy, but with a company like 3D Musketeers, we simplify the process for you. If you are tired of dealing with enders making weird noises, clicking sounds, carbon fiber, and all those fun things that just make you want to rip your dang hair out, we at 3D Musketeers can remove all that BS from you and make it very, very easy. You can reach out to us, 3D Musketeers. Links will be in the description. If you want to support our efforts directly, you can do so at patreon.com/3D Musketeers. And it's those patrons that make these videos possible. Let's get back to it. Monitor your printer, kids. That's right. I've said it once. I'll say it again. Don't leave printers unattended. Look, I know I don't particularly practice what I preach, right? These machines run unattended all the time. But there is a big, big difference, and people are going to get mad at me for this. And quite frankly, I don't care. There's a big difference between an Ender 3 and a Prusa Mark 3S. It's about $600, and that $600 goes into making it reliable without having to touch it from the factory. Now, with that being said, I won't run a Prusa in probably the first 2 or 3 months unattended because I want to make sure that everything was done right. Remember, we buy these as kits, so we could do something wrong during the assembly. A silicone sock will go a long way into helping this. It really, really can. But this is just unfortunate. How to solve it? Well, monitor your printer. They solved their own problem. It's a bit of a bummer, but they're probably screwed, right? F's in the chat. And this person's got a pretty decent move here, right? Preheat to 195 and slowly pull the material off. They've had far worse on the exact same printer, and they just bought their third one this week. You can go ahead and heat this thing up, and I highly recommend you do. Heat it up to 195, 250 if you can. Honestly, the hotter, the better. But remember, for machines that are stock like this that don't have all metal extruders, right? You will know if your printer has an all metal extruder. If it is made by Creality, it probably doesn't. And generally, if you paid less than $500 for it, it does not have an all metal hot end. So if it doesn't have an all-metal hot end, do not go above 240 degrees centigrade. But like 195, 200 is perfectly fine. I would leave it hot like that for a while. And honestly, gravity might do its work for you. But in a case like this, that's when it's great to have spares, and even better, to have a mutant. That's right, we got our hands on a Wham Bam mutant, the mutant quad even. We'll be doing a full unboxing of this coming for you next week. So get subscribed if you want to learn more about this. This is the V2, and from what I can see, all of the issues with the V1 have been resolved, so I'm very, very happy to see that. Silicone sock, get that baby heated up, and pray, right? But again, monitor your printers. This one is not so much a failure, but a question that I think a lot of people go through. I think it's valuable to throw it in here for you guys. PLA nozzle question. So they recommend using a harder nozzle than the OOB brass one. I don't know what OOB is, but it's brass for printing. Question: how much of a big deal is it to forego that for a quick print? Is it going to hose your nozzle in a single print or longer? Just trying to sort out how anal I need to be on that. Well, technically speaking, and if you want to learn more about it, you can look at our Sanjay interview series. We'll card to that right there, where we talk about carbon fiber and gigapascals in the first episode, and it only gets better from there. Do not run carbon fiber through a brass nozzle. Do not run glow-in-the-dark filament through a brass nozzle. Glow-in-the-dark is also abrasive and can damage brass nozzles very quickly even. And yes, 50 grams may not do that much, but if you go from a 0.4 to a 0.5, which is not all that much of a change, that's a big change when it comes to slicer settings. An E3D Nozzle X is not expensive. They're like 30 bucks, something in that range. They're very, very affordable. And if you're gonna spend the money on some carbon fiber PLA, good carbon fiber PLA is gonna run you at least 30 bucks a kilo. You might as well buy a good nozzle for this. Now, look, if you got a bunch of brass nozzles laying around and you don't care, change out the nozzle you're using, or no, you're going to destroy it, but you can change it out for a new one that you're going to destroy, or destroy the one you're going to be using and then just replace it. Brass nozzles are cheap as chips, but remember, not all nozzles are created equal, right? Your clone E3D nozzles are not going to be anywhere near as good as a true, genuine E3D nozzle, and I would say same goes for your Creality nozzles, but I'm honestly not certain. I did just get some Creality tungsten nozzles in. That'll be a fun video. Get subscribed for that one. I think it's worth upgrading. It's a good upgrade to have. It's not a ton of money, but if you do want to use a brass nozzle, pitch it when you're done. Anyways, there you go. Fails all over the board. Whether it is sounds coming from printers, carbon fibers, retraction issues, y-axis banding, and many, many other things, we are here to help at 3D Musketeers. Make sure that if you want to get your fails in Print Fail Friday, and look, I don't just make fun of people. I am honestly trying to solve problems here. You can tag us on Instagram, tag us on Twitter, use the hashtag PrintFail. We will do our best to take a look at them and add them into the next video, because it is important to go through these failures. We had a good look at failures today. All of them were FDM, which is pretty interesting, and not all of them are that big of a deal. With a little bit of extra knowledge and a little bit of patience, you too can stop making failure an option. Hope you guys enjoyed this one. Make sure to leave a comment down below what you thought. Which was your favorite fail, and which one do you think did I get wrong? Did I get any of them wrong? I'm curious to know your opinions. Anyways, guys, stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Oh, shit. This is a direct drive printer. Ha! Roll with it. Roll with it. Let's just roll with this. Hey, thanks so much for watching this video, and a huge thank you goes out to our patrons. Without you guys, none of this would be possible. And if you want to get your name in our end credits, make sure you head over to patreon.com/3dmusketeers and join with the $5 or higher tier. Right below me is going to be the entire Print Fail Friday series. So if you want to see more fails, you can do so right there. And next to it will be our Ender 3 series, because the Ender platform seems to be the vast majority of problems that we see things from. So we're going to keep putting those in there until people learn a little bit. Failure is always an option. We are here to help you guys make it less of an option. I'll see you all down in the comments. Take care.